ये है मास स्प्रिंग प्रॉब्लम जो बहुत सारे लोगों ने डिस्कस किया ऑनलाइन, ये सॉल्व किया भी टीचर्स ने, और उन्होंने एक कन्वेंशनल तरीके से इसको सॉल्व किया है। तो कन्वेंशनल तरीका क्या है इन चीज़ों को सॉल्व करने के लिए? जब भी जहाँ मास और स्प्रिंग का जो प्रॉब्लम्स है उनमें हम क्या करते हैं, या तो टोटल पोटेंशियल एनर्जी हम निकालते हैं पहले, और उस पोटेंशियल एनर्जी का क्या करते हैं, उसको डिफरेंशिएट करके फोर्स निकालते हैं। So that is the easiest possible way, because potential energy is scalar and it is very easy to find the potential energy components of the problem. Once we differentiate that, or once we find the differentiation of potential energy, we find force. और force equation से हमें पता चलता है what is the frequency or what the time period of the mass, this mass or that mass. The second method is writing directly the force equations for this mass and this mass. That is also very easy. Just push this mass or this mass a little away from the equilibrium position and find the forces. Once we find the forces, we can find the time period of the oscillation of this mass or this mass. But here I must tell you that you can write two equations for the masses, one for this mass and other for this mass. And once you have two equations, you have to solve two equations, and those two equations will give two frequencies for the given system. That you should not forget. You have two frequencies for the given system, or you have two possible time periods. Not two time periods, it is time period something and its time period is different. No, it can oscillate with a particular time period, or the whole system can oscillate with a different time period. There are two possible time periods for the system, or two possible frequencies. But now, using the conventional methods, it has been done online. This problem was done by many teachers. But can we do it in a physics way, in a simplest possible way, without using mathematics, much mathematics? What we do is that the two masses can oscillate like this. They can oscillate like this, or they can oscillate like this, in the same direction oscillation, or they can oscillate just opposite to each other like this. So these are symmetrical oscillations. So what we do is that हम क्या करेंगे, ये दो masses जो है, when we make them to oscillate like this, there is always a point or points in the system which are at rest. So what are the possible points which are at rest in this system? When it oscillates like this one, like this, so these 2 points, this point and this point, that will remain at rest. Something like this. यूं करके ऐसे जब ऑसिलेट करेगा तो बीच में 2 पॉइंट्स ऐसे जरूर है, या कुछ पॉइंट्स ऐसे जरूर है वर्टिकल लाइन पर जो रेस्ट में है. सो दिस विल ऑसिलेट with some time period, this will also oscillate with the same time period.
So basically the concept is sir कि जब ये ऑसिलेट करेगा तो बीच में ये जो पॉइंट्स हैं, ये 2 पॉइंट्स ये स्टेशनरी रहेंगे,
they will remain stationary. They will remain stationary. Now it is very easy either to find the time period of this mass or this mass. So the problem has been reduced to half. So we can delete this part now. I will make this part now relevant. So how can I redraw the diagram? It is like this. It is a spring here. It is a mass here. And this is now half the spring here, half the spring here. And these 2 points are at rest. So I will replace the rest points by a fixed plank or some fixed stand. But now it is half the spring. It is spring constant 2K. It is spring constant 2K. That is already you know. The shorter the spring constant, more is the shorter is the spring, more is the spring constant.
Yes. So
as you
basically,
know,
sir,
spring is inversely proportional to the length.
Yes, sir. Basically, sir, इस क्वेश्चन को हमने 2 सिस्टम्स में तोड़ा सर.
हाँ,
राइट
yes,
सर.
obviously.
तो अब हम आगे इन दोनों सिस्टम्स का फ्रीक्वेंसी टाइम पीरियड बिल्कुल सेम रहेगा.
से obviously.
So हम ये वाला पार्ट भी ले सकते हैं, ये वाला पार्ट.
हमने ये वाला पार्ट लिया और ये पार्ट को डिलीट कर दिया, because that will it is one and the same thing. So how to find the spring the mass time period of this system? So how it can be done is like this. These are the 2 in parallels. So it is spring K and mass M, and now these 2 springs can be replaced by a single spring. that is 4K.
4K पैरेलल जब होता है
Because
तो
as
सीधा
you
add
know,
होता है सर।
because as you know, when the springs are in parallels, the forces add up, stretch is the same, or compression is the same, and two spring constants just add up. And now these two springs are also in parallels. Physically, you feel they are in series, but they are in parallels by definition. So why should they be in parallels? If you push it
सर
on,
इस पॉइंट को आप यहाँ पे पूरा सर बच्चों को ना समझाइए, क्योंकि बहुत सारे बच्चे, मतलब मैंने खुद देखा है क्लास में, इस तरह के जब प्रॉब्लम्स आते हैं तो बच्चे कंफ्यूज होते हैं। वो समझ लेते हैं कि ये वाली स्प्रिंग और ये वाली स्प्रिंग सीरीज में,
हाँ,
बट दे आर इन पैरेलल। इस चीज को आप थोड़ा
बेसिकली ये है पैरेलल और सीरीज का ये है कि फिजिकली इट मे सीम टू बी इन सीरीज, बट इट इज बाय डेफिनेशन दे आर इन पैरेलल्स. सो बेसिकली वी हैव टू अंडरस्टैंड व्हाट वी मीन बाय पैरेलल्स. Parallels means if the force add up in the two springs, or the stretch is the same for two springs, then they are said to be in parallels. So if you push the spring onto the right side, this gets compressed.
Yes.
How much? Let me say it gets compressed by X. At the same time, this gets stretched. At the same time, this gets stretched. That also by X.
Yes, sir.
When this gets compressed, it will produce a force in this direction. When this gets stretched, it will also create force in the same direction. So forces have added, and stretch is the same. So by this definition, they are in parallels.
So basically, sir, हमें क्या देखना है? We have to find the direction of force and the direction of extension.
Yes. But
if the direction of force are same, then they are in parallel.
If the forces add up.
Yes, sir.
If the forces add up, and stretch is the same, then they are said to be in parallels. So by definition, but seemingly they seem to be in series, but that does not make any sense. Anyway, so still we are not using any mathematics. हमने अभी कोई मैथ इस्तेमाल किया नहीं. We have just used physics concept that these 2 points are at rest, and we have just segregated the system into 2 parts, and we are finding the time period of one part, and other part will also have the same time. Okay, now they are in parallels.
Yes, sir.
And what is the time period now? Mass spring system. When two springs are in parallel, there is 2 pi root of only single mass divided by 5K. That is the answer. So why we should use any mathematics or detailed analytical analytics or heavy potential energy expressions? Now there is one more time period possible. That time period, I'm asking you that question. You try to find that time period and give the answer in the this comment box. And in the next lecture, I will find the other time period also. But let you do it yourself. Any question you want to ask?
Sir. बेसिकली सर मैंने खुद भी देखे हैं, ऑनलाइन भी बहुत सारे टीचर्स इसको एक्सप्लेन करते हैं. सो मेनी टीचर्स ऑल ओवर इंडिया, दे हैव एक्सप्लेन्ड दिस क्वेश्चन, दे हैव, बट सर बहुत ही लंबी कैलकुलेशंस
उसमें ये है कि they are writing the basic equations for this mass and this mass. When they write basic equation, definitely analytics that will extend. And they are engineers, they know more mathematics.
Yes, sir.
They are doing most of the things through mathematical calculations. And physics people will try to do the things just by applying his mind.
Yes, sir. So आप देख रहे होंगे बच्चों कि एक छोटा सा कॉन्सेप्ट यहाँ पे फिजिक्स का यूज हुआ, and this question has solved in single line. एक single line में solve हो.
I want to give you a hint for the other time period. Now the masses will oscillate. They were already oscillating like this, keeping the middle points at rest. But they can now. There is one more possible oscillation that is like this, and you think yourself how it can be solved just by thinking, and just by you can just directly write the time period equation if you apply your mind.
Yes.
Thank you.
So this is how JEE advanced question can be solved by simplest, smartest way, जिसमें बहुत ही time कम